1?
So prophase 1 is the same in the sense of the nuclear membrane disappears.
Good.
The chromatin condenses into chromosomes.
Nice.
The spindle forms. And then the main difference is that crossing over occurs.
Show me that. Let's see crossing over. She's a genetic engineer. Look at that. Too much pressure.
Yeah. So crossing over occurred there.
Beautiful. And,
And
then
then
they paired up, huh?
Yes.
So like homologous chromosomes
Homologous
paired up and
chromosomes, yes.
they crossed over. Now how come the little ones aren't paired up? They should be paired up, don't you think?
Well,
They mad at each other, got in a fight or something? So they're paired up. But they didn't cross over. Is that okay? Does that happen sometimes? Yeah, it's random, right? So you might cross over, you might not cross over. Okay, so that happened. Okay, now what?
in metaphase 1, the homologous chromosomes line up in the middle.
They stay paired up as homologs.
Yes, as homologous
That's
chromosomes.
new. This is all new stuff. This is cool. Okay,
And then
now what happens?
in anaphase 1, the homologous chromosomes get separated
By the spindle?
by the spindle. Yes.
That's cool. But the centromeres don't split.
No, they still stay connected.
Okay, so anaphase 1 is different than the anaphase that was in mitosis, huh? Okay, thanks. I'm just trying to figure this out.
So, at the end of telophase, cytokinesis occurs, and you end up with 2 homologous chromosomes in each instead of 4.
Wow, reduction division.
Yes.
Half. Beautiful. Tears. Okay, now what happens next?
So, in interkinesis, you duplicate the centromere.
Good. So that's really the only thing you need to do. Duplicate the centromere. In order to do what?
In order to be able to pull the apart.
So in order to make another spindle, huh? Okay, good. Okay, now I go to prophase 2. What happens?
Prophase 2, the spindle reforms.
Okay, good. Good. So
Um,
it connects to them. And now metaphase 2?
In metaphase 2, they meet in the middle.
Good, because now you can connect to both sides, right? They're no longer homologous, because the homologous one to this one's where?
On the other cell.
The other cell. Yeah, okay, good. And then what happens?
And then in anaphase, they're separated by the...
So the centromeres actually split here, like mitosis?
Yes.
Nice, look at that. So you end up with 2 here, 2 here, 2 here, 2 here. These are unduplicated chromosomes, aren't they? Yeah. Okay. And then what happens at the end of telophase?
At the end of telophase, because of cytokinesis, you end up with 4 different cells with completely different DNA chromosomes.
Look at that. They're all different from each other. So if these were 4 sperm cells, wouldn't they all make a different child, right? Or egg cells. One of them's an egg cell. The rest are polar bodies. They disintegrate, right? You could have one of them, and you could say, oh, this one, you'd have like all mom for these genes, all dad for these, but then more of a mixture on these. Does that make sense? That's really cool. I like it. And then we're back in metaphase 1. The way they lined up in metaphase made a difference, because you could get different combinations by the way they lined up in metaphase. Let me show you real quick. So if I had, this one and this back together again, and they were in the middle, like in a metaphase, and these guys, and then they separate from each other this way in anaphase, you get this type of mixture. But if they're in metaphase like this, and they separate, you get more of mom and dad on each side. See that? So it's called independent assortment. How they assort in the metaphase is really important, as well as how they cross over in prophase.
Is that true for metaphase 2 as well, or just metaphase
Just
1?
metaphase 1. Yeah, metaphase 2, it's like mitosis. Matter of fact, the whole division, second division, is like a mitosis division. Okay? Good job, you guys. Okay, so you just have to clean up everything, put all the chromosomes back.